So I will be delivering the talk on IoT hardware and standards. So in that case, I will be looking for the sensors and actuators used for this thing. Then the communication protocols are there. But prior to, so this is the way I will start it, and this is the way I will be delivering the talk, like part of the introduction. Maybe you have heard it some because the IoT is hot cake now in the market, and maximum people, they might be knowing two words or two
This
projects
conference
or
will now be
small
recorded.
projects you can able to work it. But when you are going to deal with some of the bigger projects, okay, like some sponsor or government project, or think of that for a smart city you are working, then it needs a very depth in knowledge to carry out that project successfully. For that, I will be showing you some part of your architecture of the IoT, then talking about the hardware part, what are the hardware it is using. See, in the morning session also, Dr. Bijay, he has shown some of the simulation things in the Tinkercad using that Arduino boards. Okay, basically in the Tinkercad, it is only providing the Arduino things, and the various other boards are also available. Mainly, though, if you are working on the IoT, then definitely you need to have the knowledge on Raspberry Pi. So how to handle that board, how to connect the internet, how to connect this sensor actuator. And after that, if you have all those knowledges, then definitely you should be having the knowledge of your this communication things. Okay, so now, so I will be continuing with the layers, IoT enabling technology, IoT levels, and deployment templates. Okay, and what are the challenges and futures for this? Okay, so when you are coming to this thing, like the internet revolution, when I'm talking about the internet of things, then definitely we need to talk about this internet, because this is the very foundation for the IoT. Foundation means, if the IoT, was it there? Yes, it was there even 20 years back, but it is somewhere like ideal situation it was there. Like, we are not communicating through the internet things, it means through this internet. But now we are connecting with the internet and transferring the what are the informations we are collecting, and the information which is required to resolve some of the problems, either it is in the society or it is at the institute level, like some of your research level. Okay, so those things are there. So IoT was, it was there. So prior to that, we are talking about this internet. If we will come to the internet, it is the era, like, or I will not talk about the era, it is the time bound of, you will see, that is your 1969 to 95. Okay, so that was the time of your internet of boffins. That means it is the initial stage, and so many people are involved to develop it, to progress in that case, to provide a stable and a sustainable solution to use this internet, how it will be done. So those things are there. Next, it has come to the 95 to 2000. That time, it is the era of your internet of gigs, or the time of your internet of gigs. That means who are very much familiar, or who are, we can say that very much interested, taking interest, they were only able to work with the internet in 95 to 2000 time. But that time, when it has come to 2000 to 2000 time, it was 2007, it was the time of your internet of masses. If I can remember, during that time, I was in how I used to access the internet is to visit one of the cafe in our town. There used to be some 3 to 4 cafes, internet cafe. In that, you have to be in queue, or if you are getting some computer to use it, then you have to pay per hour basis. So per hour it may be 10 rupees, 25 rupees something, and with that hour you will be checking your emails, and or you are sending some mails like that. Some, if you are getting some information about your somewhere you are joining or you are taking admission. So those things we used to do in the 2000 2007. So it was for masses but limited. That means nowadays how we are accessing the internet every time, anywhere we are there, we are connected with the internet. So that was not the scenario at those times. Then it came for the 2007 to 11, that was for the mobile internet. Because prior to that, in 2000 2007, basic phones used to be there in the market, and in the basic phone there is a very limited chance to connect the internet thing. So when the time of your 7 to 11 was there, that time even the mobiles were able to access the internet continuously. So that was the continuous, means that was the the internet it is used in the mobiles. Then it came for the your 2012 and beyond, for this your this internet of things. Like it was there, but still it was people used to, means see, internet of things, it was there previously also. And the name if you will say, then it was the name of your, if you can say, embedded system, or you can say real-time embedded system. That is type of your connections, the same embedded system which is stipulated to the time thing, and with the information passing through some of your communication thing, just like your internet. Those things are your RTS thing. So if you will see, it was existing, but now it has evolved with a different name. If you will see the impact, of your internet, then I can tell you that it has a huge impact. Because of the internet only we are here. I am sitting here at Jamshedpur, but my organizer team, they are sitting at Institute of Technology Gopeshwar, and they are controlling whole program. And the participants from throughout the India, they are able to join or take admit into the platform, where they can able to hear it, they can get the knowledge, they can digest it, they can ask some questions, and they can clarify their what are the necessary problems are there. So this is nothing but the impact of internet. So that is the real, I can say that, people used to say burning example. So that is the real and burning example, is nothing but what we are. Just now I'm delivering the talk, and people are listening my talk wherever they are sitting, either their home, office, if they are in somewhere they are traveling. With that also, if they have connected the mobile with the internet and they're connected, then also they are able to get it. So through that, if you see the huge impact, it came to education. See, previously also it was there in everywhere, but the COVID-19, but the COVID-19, it taught us so many lessons, and one of them is to get the education through internet. See, this is nothing but your online education, getting the online education. Though you have taken admission into any IIT, any NIT, or any of the reputed institute or engineering institute, but still you are sitting in your home and getting the education. That means your education has not halted, it has not paused. The education, it is continuing in terms of your online way, through the internet. So that is e-learning. So those are nothing but this thing. Business, so business, it is, see, the Amazon, Flipkart, Mantra, these are the some of the great outcomes of this internet business. if you will see, you are sitting your home and you can scroll their app and able to select some products, see the prices, either pay it on through this online payment thing, either the GPay, Google Pay, those thing type of thing, or the cash on delivery. But but still you can able to purchase it through this internet, and the persons who are involved with this business, they can able to successfully carry out their business thing. Communication, obviously, if the education is happening, the communication is also happening with us. Okay, so we are connected and we are talking each other, either it is your without camera or with camera. That means, see, I can give you one example of my childhood. That time I was in hopefully in somewhere fourth standard, fourth. That time one of my friend was there. So that person, in his home, he has some this landline phone was there. Okay, so once I asked that, so how you are talking to your uncles? Let's see, we have our landline phone is there. Then I said, how it is looking like? So he took me to his house and shown me that this is the landline phone. Then what he said, see, I know one phone is there where if you want to see the person who is talking from the other end, you can able to see it. Then I said that, see, this person is, see, I was in standard 4, so able to think. I was not able to think that much. But nowadays this communication, how it has evolved, that you can able to see, do the video chat, either you can make it only audio chat or video chat, the single thing, or in a group also you can able to make the chatting, those things. So like that, in terms of entertainment also, uh, again I will say this, during this COVID-19 time, people, this all the OTT thing, means online, this entertainment platform, OTT things were able to make a huge business. Either it is your Disney Hotstar, you can say G5, okay, so Sony Live, those apps, they able to make it this type of your use of this internet and make their entertainment successful thing, and people used to access also properly. So if we will come to this usage thing, if I will talk about the how the internet it is using in 2003, the connected devices, I will come, if the total population in the world was 6.3 billion, that time connected device was only 500 millions, and connected devices were 0.08. Fine, this is okay. But as the time progressed, if you will come to this 20, or we can say that 2021 also, the 2020 I'm just talking about, this time 7.6, around 7.6 billion people are there, and with that 50 billions devices are connected with the internet. Okay, so why we are talking about this information? Because these are the information through which we can see that whether the internet of things is a successful technology to be invested or to be invested in. That means if we are investing some money or our knowledge, in that case, whether it will be a successful thing or not. So for that, these previous analysis are very much necessary. And I'm talking about this thing, so it is saying that around per person 6.58 devices are connected. Now I will talk about one of the thing. So just this is the theoretical thing I'm saying. Now I will take my case, my example, and I will say that how it is 6.58. Okay, so I have one mobile, fine, that is connected with the internet, one is connected. So I have one tablet that is connected with the internet. I have one TV that is also connected with my internet, and I have one smartwatch that is also connected with the internet. I have the laptop that is connected with my internet. Then one of the desktop in my office that is connected with the internet. So just think of, So like this, it is coming around
Hello.
6. Yes, yes, someone saying something. Okay, okay. So if you will see, it is nearly 6 devices it is coming to me. So like that, if you will talk about others also like that, if you will make it, so definitely it will go beyond, and minimum it is on an average, it will come around 4 to 5 per person. So this is the case. I have taken one of the sites from broadband search. In this case, how the internet usage and population thinks it is coming, the rise of mobile traffic and current scenario thing it is given. So like in 2009, only 0.7% it was there in that mobile traffic thing. But if you come to 2020, how much it is coming? And if you will see the total usage in the worldwide, who is using, why we are saying, because if you want to do the business at what place, if you are working, then you will be more successful businessman. So for that, see why I'm saying businessman, because if you will be a researcher, then definitely our product, what we are doing through the research thing, that should able to convert into product. If it is making into product, then only that is a successful research work which can fetch some of the money, and for this thing, so that will be useful the betterment of your society. So that is total internet users worldwide statistic, how much users are there. With that, which is your highest thing, it is there. So around North America is around 7.2% contributing. Then Latin America, that is your 9.5%. Africa, so this is your 632 million people they are connected, so that is nothing but your 12.8%. And so like that, if it is there, so connected world, so how it is 70% is the mobile. From out of this, the conclusion is nothing but the internet is connected, means the 70% of your mobiles are total, out of the total devices 70% is nothing but the mobile thing which is connected with the internet. Now it is coming to the internet of things. Like Kevin Ashton in 1999, he has coined this word. And I told you also, this IoT was not a new thing, but the way it has packaged, it looks like new, but earlier also it was existing. Okay, if it was not there, then tell me how the people in NASA, they are able to communicate with the devices sent to any other planet, or just like they have sent some of the devices to moon and collecting some information from there, and from here also they are able to able to control those things. So it was there, but in a smaller scale, and limited persons or limited devices it was connected. But now everywhere, if you will see, the internet is there, internet of things is there, various names, and the one concept is that. So why this image is given, so if you see, this is nothing the screenshot of one of the Terminator movie. In that case, they have taken the word of your Skynet. Okay, it is nothing but the same IoT. Now how many names are there? There are various names are there. Out of that, M2M, machine to machine, internet of your everything, Cisco system. They used to say that internet of your everything. If you will ask about the Cisco systems, and you will get some information about this thing, then the same IoT, it is called as the internet of your everything. Then from the Brusiner, it is world size web. It is not worldwide web. This is your world size web. And what is IoT? This IoT is nothing but a network of your objects where various devices. I will come to this one. I will talk about this thing. Okay. So IoT, internet, all of us got this information now, where it has started, how and how it is putting impact in the society. And the things, I will remove this off thing. The things we will talk. This things is nothing but the sensors, or I will say that the things are nothing but the nodes. And what is this nodes? This nodes maybe consist of your sensors or of your actuators. That's why these sensors and actuators are the, I can say that building things. If you will say the basic building things are nothing but these sensors and actuators. The Internet of Things, also called the Internet of your objects, refer to a wireless network between objects. Usually the network will be wireless and self-configuring, such as household appliances. Now, so many various definitions also existing, just like the name of the IoT, various names also existing. So now, if I will say in terms of your IoT 2008, what they used to say, the term Internet of Things has come to describe a number of technologies and research disciplines that enable the internet to reach out into the real world of physical objects. The same thing what I'm saying, the if you know the concept of your IoT, how it is framing, then you can able to in what are the field you are there presently. If you are working in any of the field, then immediately you can correlate how your research will be implemented in the IoT, or this IoT concept can be utilized in your present research scenario. Okay, now slowly I'm moving, because some of the definitions after that the IoT means IoT thing we came. Now, before going to the other technology parts, we need to hear the management parts also. Because see, if you are just, I will say that one of the, again I will one example, I will say that one wall is there, and every day you are taking your food and going to sit one side of the wall and pushing it to backside. Okay, just like you are pushing the wall. But even after 1 month, 1 year, even 10 years, you cannot able to push it. Okay, the wall will be same at the same place. So that's why if you're working somewhere and you are not getting benefit out of that work, then definitely you should not work in that place. Whether you will come to some other side where you can contribute something. Just like that, if we are working in some of the research areas and we are not getting benefit, just like your IoT, if we are not getting any benefit, then why we will be going to for that? That's why I will be talking about some market scenario. In 2013, the 9.1 billion of your IoT units are there. And in 2014, in terms of your money, the US, the revenue was from the IoT market, the revenue was total 605 billion US dollar was there. And they were said that they were expected that it will be growing to some of your 20, see this is your 9 billion was there, no, so it will be around 28.1 billion IoT units or IoT devices will be there in 2020. Will be there means people were using for this IoT devices. That means there is the exponential growth is there. That means if we will invest our hard work, our pain, then definitely we will be beneficial, either in terms of your knowledge or the money thing. According to IoT, or according to this the market side, the IoT thing, it is going to be beneficial. So if you will see, so many other things also presented here. Then through this graph thing, if you will see, where this IoT thing will be there, the consumer electronics, manufacturing unit, healthcare, retail section, transportation, or other things are there. So there are various colors are given. If you will see, as the years it is passing, by 21 what will be there, by 22 what will be there. If you will say the consumer electronics, it is growing faster, this consumer electronics section, because your smartphone, your even you what is this either your mobile thing or your tablet thing, what are consumer electronics are there, in those cases it is growing faster. Even nowadays the healthcare also, see in because of this COVID-19, government has also displayed some of the projects, like they have called for some proposals related to the healthcare, and they're connecting this IoT thing, just like you're controlling the SpO2 or the oxygen level thing, or providing the oxygen to the patients affected due to the COVID thing. That will be done through the IoT, the application of your IoT knowledge or technology. So where is IoT? It's everywhere. It starts from your industrial automation, smart health, home, city. So everywhere you will be able to visualize this IoT thing. Okay. So even if you talk about the educational institutes in the campus, it is there. If you will start it from the personalized learning, adaptive e-textbook, just like we are looking for the PDF thing, digital classroom, whiteboard and displays. Okay, so video recorders, lecture captures, so many things are there in the campus. So see, this page itself, it will, if I will talk about each of the thing, then this one will only take around 1 to 2 hours to complete this PPT only, this slide only, because we will be talking about, think of this, it is saying that the whiteboard, some one word it is given, how this whiteboard will be used in terms of IoT. Now just one example I will put it, and after that I will move it. So think of that, the whiteboard, it was there, and one of the faculty person, he has written something on this thing. And think of that, when he is writing on that thing, behind, in the offline class mode I'm saying, in the behind, if people are not listening, or if they want to talk among themselves, then there will be a noise disturbance to the faculty member. Okay, that is one side. Think of that, this thing is over, and the faculty member is talking to the people in front of him, and he need to move to the another topic to write it here. So meanwhile, what will happen when he is erasing this thing, that time also, because that time one type of your break, like 1 minute or 2 minute type of break, it will be for the students. So they, that time also, if they have something in their mind, they will start discussing with their friends. Now to avoid this thing, if we will use the IoT to clean the board thing, think of that, this will be two motors will be involved, and one wiper will be connected with this thing. So this is a just like a conveyor belt type of thing is there. Now suppose that what are the discussion is over on this thing, the faculty member want to erase it, then if he is holding one phone, and with that thing he will put a button or press that erase or wipe it out, then he is looking to the student. Meanwhile this motors will start running, and with that this wiper will clean whatever the board is there. So that way, this is nothing but use of your IoT thing, you can able to clean that board thing. So just like that, whatever the topic is there, we can start discussing, no problem with that thing. But we are going to the sensors and actuators. Enabling technologies, if we will say who are there behind this IoT the making this IoT successful, there are so many technologies are involved. So out of that, RFID to identify and track the data of things, then sensors to collect and process the data to detect the changes in physical status of things, smart technologies, that is to enhance the power of the network by evolving, okay, or developing the processing capabilities of different part of the network. Then nanotechnology to make the smaller and smaller things have the ability to connect with the world. Then from the technical perspective, see, IoT, we heard it, the example we got means the definition we got it, how this IoT is framing, that one also we got it, the market size we got it. Now we are moving into the technologies inside IoT, how it is making us. So from the technical perspective, it is your, how it is, there are three layers are there: sensing layer, second is your communication layer, then last is your management layer is there. mainly these two things. So some part of your these two things, because even the communication layer, it is not a small thing. It will take also, if you will talk about this thing, then also it will take too longer time. So some part of your sensing layer and this communication layer we will be talking. This management layer, it is nothing but the work of your machine learning algorithms, the machine learning algorithms, because from here the data or information will be collected, the sensing layer thing. Now communication layer, it is going to fetch this one, and it need to move that information to the management layer thing. Whatever the in the management layer, the machine learning algorithms, they are deciding same thing through the communication layer, it is coming to this layer. So here again we will say that this is some actuation layer, we will say it. Then through that we can able to qualify, or we can able to execute whatever the problem is there. Suppose from sensor we are taking some information about some water spraying, that we need to spray some water, and the communication layer it is collecting, and in at this one it said that yes, the water layer is going down. In that case we need to start the motor to provide this water. So that is nothing but you, the sensor layer, it is working. So communication layer, it is nothing but the communicating or exchanging the information between the sensing layer to the management layer thing. Okay, so one minute. Okay, so till now if anyone has some something to ask, then they can ask me. So I will be providing you 1 minute, so that if you have some interaction, if someone want to interact me with this thing, because from this we will come to the main topic thing, and it will continue. Okay. So yes, so architecture of your internet of things, basically it is saying that the essence of your IoT architecture, it is consisting of your sensors, actuators. These two things we can make it one, because this one we are saying that nodes. Okay, then protocols, various protocols are there. Okay, for communication. Okay, then it is coming as the cloud service. In the cloud service, as as PaaS, SaaS, those things it is coming. Okay, so then the various layers are there, just like we have seen the management layer, those things. So stages of your IoT architecture is sensors and actuators, internet gateways, and data acquisition systems, edge IT, then data center and cloud. So one by one I'm starting. So this is the sensor and actuator I will be starting. Now people might be heard of this thing, the because in the, I think in the morning session you have seen some of the sensor things in the Tinkercad thing. Okay, so now I'm going for the working principle, because it is not only that which sensor you will take it, but you need to know about how it is functioning and the library files. Why these library files are required? Because uh, we need to design also. Suppose I will take a temperature sensor. Okay, then either you need to make this library file for this one. So for that you need to know the hardware thing, how it is functioning, with the what excitation it will be able to capture the temperature thing. So a sensor, for the definition thing, if you see, a sensor detects or changes the ambient thing in the state of another device or a system. Not okay. So a sensor detects or senses changes in the ambient conditions or in the state of another device or a system, and forwards or processes this information in a certain manner. That means it is nothing but, if you say, through this Oxford dictionary, if you will come, a device which detects or measures a physical property and records, indicates, or otherwise respond to it. So that is nothing but what. So these are the some of your I can say that technical words. Come to a very known thing. Come to a very known thing, that is a thing that our nose. So through this we can able to smell. So how this is, some, that means some physical variation is there, physical property variation is there, that thing we can able to detect it. So that's just like that. In a sensor thing, it is nothing but it is either the pressure thing, I will say that. So if a pressure sensor will be there, and through that, if I'm providing some pressure to this one, then through the technology way, there is a capacitive type of your the pressure sensor is there, where if you will see, so think of that there are two plates are there. So one is your fixed one, this is your fixed one is there, so another will be moving one will be there. Okay, so in that case, if I'm putting some pressure to this one, then this is inclination it is happening, and because of this one, the deformation of this thing, so the distance between these two plates, it is changing, and with that it is giving you some of your capacitive variation in the capacitive values. So with that type of thing, it is a capacitive sensor it is making. So that is nothing but you the that is nothing but how much, what are the capacitance thing it is changing, that is indirectly it is giving you that how much pressure it is occurred on the plate thing, on the above plate thing. So like that, we can have various type of sensors are there. So what they're doing, they perform some input functions by sensing or feeling the physical changes in characteristics of a system in response to a stimuli. That means if we are providing some excitation to that one, with that it can able to sense it. It means it can able to determine some variations in the outer world thing. For example, heat is converted to electrical signals in a temperature sensor, or atmospheric pressure is converted to electric signal in a barometer. So as we are talking about the sensor and actuator for the IoT, then there is transducer also. Transducers convert or transduces energy of one kind into another. That means if I'm providing some electrical signal and it can able to convert into the mechanical thing, so that is a transducer. For example, in a sound system, the input device is your microphone, which is converting the sound waves into electrical signal for an amplifier to amplify or process, and loud. It is giving the output device as the loudspeaker thing, convert this electric signal into back to sound. That means from my microphone, what just now what is it is happening, from my microphone I'm talking, and what are the signal I'm saying, that suppose this one I'm saying that hello. Okay, so that in this hello thing I'm saying, so think of that the signal, it is nothing but something it is happening. So this thing it is converted into some of your electrical part thing. Okay, and with the same thing your side, this electrical thing again it is converting into some of your web thing. Okay, and because of that it is giving you some sound, means what I'm saying, the same thing you are able to make it. So this thing also required, not necessary, but you need to know what is the transducer and what is sensor. The word transducer is the collective term used for both sensors. That means in the sensor also definitely you are sensing something, that means you are determining some changes in the outer world, and you are converting that thing into your electrical signal, then only it is indicating. So collective term used for both sensors, which can be used to sense a wide range of different energy forms such as movement, electrical signals, radiant energy, thermal or magnetic energy thing. And actuators, which can be used to switch voltages or currents. That means actuators means, if I will say that if a motor is there, I want to actuate or excite it or start it, then I need to provide the electrical supply, some voltage I will give it, and because of that the rotor, the winding what are the blades are there, they will start moving to this one. Okay, so with that it is able to make it some mechanical motion thing. These are necessary because what are the sensor features it is required? It is only sensitive to the major property. For example, a temperature sensor senses the ambient temperature of a room. That means what are the sensors are there that are dedicated to detect or sense the one primary part or primary property thing. It is insensitive to any other property likely to be encountered in its application. That is, a temperature sensor does not bother about light or pressure changes, okay, while sensing the temperature. That means this is the features that if a temperature sensor is there, so why these things we require? Because think of that, if you want to make your home as a smart home by the application of your IoT, then in that case think of that the AC you are using, and that AC will be operating as per the temperature thing. So you will be using some one temperature sensor and connecting this AC thing. Just I'm giving one example. It will not bother whether it is the day thing or the night thing, but if there is a change in the temperature, then directly it will convert, means it will connect with the AC either to switch on or switch off. See, why day and night? In the daytime you will be getting more lights, but in night time you will not get that much of light. So it is not bothering about the light thing, it is only bothering about the temperature thing. So sensor resolution of a sensor is smallest change it can detect in the quantity that it is measuring. So that is the resolution thing. Fine. Basically this is necessary. The how many the classes are there based on output. The sensors are divided into analog and digital. Based on data type, it is based on your scalar and vector thing. So why we are saying this thing? Because again I will say that we need to select or choose a proper sensor or proper actuator for your application. Analog sensors produce a continuous output signal or voltage which is generally proportional to the quantity being measured. Okay, so for example, the temperature of a liquid can be measured using a thermometer or thermocouple, okay, which continuously respond to the temperature changes as the liquid is heated up or the cooled down. So in this case, directly it will continuously it will detect. So that is nothing but your analog type of sensor thing. If you will come to digital sensor, then it is a discrete type of thing, it will result it will provide. Just like in digital sensor produces discrete digital output signals or voltages that are a digital representation of the quantity being measured. So digital sensors produce a binary output signal in the form of a logic 1 or 0 thing. But this is a non-continuous. It is not the continuous thing. Once it has given some value, it is changing. So that one it will give it, then it will stop it. Again you need to remove it, again you will just put it, then only it will show you the some different value if some changes are there. But in analog thing, if you are putting this sensor thing, the thermometer, continuously if the temperature it is increasing or decreasing, then it is indicating in that sensor thing. Scalar, we know this scalar and vector thing. Scalar sensors produce output signal or voltage which is generally proportional to the magnitude of the quantity being measured. Okay, and if we'll come to vector, it produces output signal or voltage which is generally proportional to magnitude and direction. So what is this thing? If you will see the physical quantities such as sound, image, velocity, acceleration, orientation, or means those things all are vector quantities, as only their magnitude is not sufficient to convey but the complete information required. For example, acceleration of a body to be measured using an accelerometer, which gives the component of your acceleration. Fine. So now here are the some of your sensors names are there. So one by one we are going through that. So that is your, if you will see, I want for the light detection, where it will be used, where it will be used. If you will see in smart city project, if you want to go for the smart city, because government of India has declared some of the city to make it smart city. For that also he has disbursed some of your amount, some in 1,000 crores. So if you will see in that case, the light which is glowing beside the roads, and those light things I want to make it smart way switch on and switch off. For that I need this light sensors. That means what is the light is there outside environment, according to that it will be switching on the light or not. So for in from the light point of view, it is light dependent resistor, that is your LDR, or the photodiode thing is there. Then temperature, thermocouple, thermistor. So because see these things are some of the thing, means some of your bigger sensor will be also there, but for temperature we are having some very small, or even say that your micro level type of things are there. With the packaging it is coming into level of your sensors. That means the size is in terms of your millimeter thing. Force, strain gauge, pressure switch, position, it can be found through the potentiometers, encoders, and optocouplers. Then the speed, and then the sound, and your chemical, means the various type of your sensors it is there. So we will be going through one by one. This one, this is the LDR thing. So we said that this is the light, for light thing it is your LDR thing. So LDR is a component that has variable resistance that changes with the light intensity that falls upon it. So if you see, this is a very small device, this is a very small device, but when the light is falling on this thing, because of that it is nothing but changing that resistance thing, and it is providing you the sufficient amount of your excitation to either switch on or the switch off thing. So this allows them to use the light sensing circuit. So this is the LDR thing. So if you see the as the resistance is high, if you see in terms of graph thing, I will say if the resistance is high, then light intensity is less. Okay, so as the light intensity is increasing, the resistance it will go down. Okay, so that means the most common type of LDR has a resistance that falls with the increase in the light intensity. Okay, so falling upon the device. So if you will see in the daylight, it is your 5 kilo ohms it is making. Okay, but in terms of your dark thing, 1 2 3 4 5 6 20 mega ohm thing it is making. Okay, so this is 5 kilo ohm things, and this is your 20 mega ohm citizen. So there is a larger variation between these figures, so that if you will see resistance, if you will see from the resistance to light sensitivity. So basically we have developed one of the project when I was there at IIIT Dharwad. In that case, the students, they have used this LDR thing and worked on the smart lighting thing. Okay, and it was quite nice paper, nice work it has done, because they have developed one the app also. Okay, so what they did is the roadside the light it is there, no, with that we are using this LDR thing to detect the atmospheric light or the environmental light, in which if it is, because in manually if you will come street lights, in the manual, if you will say in street lights at 6 o'clock, at 6 p.m. they will switch on, and in the morning 6 a.m. they will switch off. Okay, so at the evening time they will switch on the light 6 p.m. and morning 6 a.m. switch off. So that is the manual thing. But think of, this is not a average day, but this is the summer time. Summer time means more light will be there. That means the evening or the darkness happens nearly around 6:45 to 7 p.m. and even the morning also used to happen by 4:30 or 5 p.m. Okay, so what will happen, from this 6 p.m. to 7 p.m. we are wasting some energy, 1 hour we are wasting, because see, I'm not talking about only one light. You say the hundreds of lights are there in the street, so according that we are wasting some huge amount of energy there, 1 hour. Even in this case also, in the morning time also we are wasting some 1 hour of your this light thing. Same thing, if you will say in the winter time, this 6 p.m. it moves down to 5 p.m. By 5 p.m. it will be the dark thing, it come into thing. That means till people used to move in the dark up to 6 p.m. So there is a loss for the people, because if they have not having any torchlight or they are not having any light, they will face some difficulty. Think of that, in morning time the fog is there, and with that it the total brightness it is coming in nearly around 7 a.m. Okay, so here also we are facing some problem. So that is resolved through this project thing. So like that, photodiode, just like in this case the resistance it is using. Okay, in this case there is a PN junction diode is there. A photodiode is a PN junction diode that consumes light energy to produce electric current. The photodiode is one type of your light detector used to convert the light into current or voltage based on the mode of operation of the device thing. So this diode is very complex to light. So when light falls on the diode, it easily changes light into electric current. That means with the falling of this light thing, okay, it can able to convert into the electric current thing. Okay, so there are incident thing it is happening because of that, the how the electrons and the holes they are moving from this side. With that thing, the depletion layer is increasing or decreasing, and it is switching on or off thing it is happening. So what is saying, the working principle is nothing but the photon is when a photon of ample energy strikes the diode, it makes a couple of electron and holes. I told you this electron and holes, these electrons are moving this side and holes are moving this side. So what will happen, if the absorption arises in the depletion region junction, then the carriers are removed from the junction by the inbuilt electric field of the depletion region. That means this depletion region, if it is narrowing down, then we can able to switch on. Okay, that means it is nothing but narrow down. So therefore holes in the region move toward the anode and electrons move toward the cathode, and photocurrent will be generated. So this is the physical principle, though you know some of the things, but still. So there are PN photodiode is there, Schottky diode is there, then PIN is there. Okay, then avalanche photodiodes are there. In terms of your temperature, because this one is also very much necessary for the temperature thing. Simple, for a smart home, you need, see, I'm not, you need not this thermocouple thing, but you need a temperature sensor thing. So basically I will be talking about the physics, how this is working, the inside thing. Because if you will purchase that device, okay, you can get for the 100 rupees or 200 rupees, you will get the sensor thing. But if you don't know, okay, you may be knowing that, okay, I will connect it with the wires and you will work it, but you don't know what is the maximum voltage you should provide, what is the minimum thing it is required to excite it. So that's why these things are necessary. A thermocouple is a device made of two different wires joined at one end called junction and or measuring end. So this is one of your wire 1 and wire 2 is there, and they are connected with here, that is your junction and thing, and this side we are providing the exciting. So this is nothing but your voltage end, or you can say that where we are providing this voltage thing, tail end thing. This is a junction end where we are detecting, suppose here the fire is there and here I want to detect. So take the information of your temperature. That means the junction side will be placed here over the temperature where it is generating. The two wires are called the thermo elements or legs of the thermocouple. The two thermo elements are distinguished as positive and negative ones. The other end is called as the tail end. So I told you this one, reference and tail end or the voltage end. The junction end is immersed in the environment whose temperature T2 has to be measured. So this one need to be T2. So for that, some electromagnetic force, this one we are calculating out of this S1 to T1 to T2 means the temperature. So this is your ideal temperature. Think of that 25 degrees centigrade. Okay, ideal temperature is there. And T2, it may be your 100 degrees centigrade. Some temperature it is more than that. Even for industrial application, it can go up to your 1200 degrees centigrade. Okay, so industrial applications in which can be instance temperature of furnace about 500 degrees centigrade, while the tail end is held at different temperature T1. Example, ambient temperature. That is how we are measuring this thing. So now with this thing, so other way is also one reference and is given, only a copper wire will be given and wire 1 wire 2 will be there, and we can able to detect that temperature. So this is your temperature to be measured, this is your junction and just the same thing. And here, because what happens directly, if you are providing this one is nothing but giving some more stable results as compared to that one. Why? Because in order to measure the voltage at the tail end, two copper wires are connected. Two copper wires are connected between the thermal elements and the voltmeter. Both the copper wires experience the same temperature difference, and as a result, the voltage drops along each of them equal to each other and cancel out the measurement of the voltmeter. Now, how it is looks like, if you will see, this is your thermocouple. Okay, this is various industrial applications it is there. So definitely we are talking about the IIoT, industrial internet of things. So in that case you need to know the concepts of this bigger sensors. Thermistor also, it is one of the temperature sensor, but this is dependent on the resistance. Once you are heating up, the resistance it is decreasing, and so what it is in cooling down, the temperature increases. So what is that? The thermistor is an element with a electrical resistance that changes in response to temperature. A thermistor is a type of resistor whose resistance is dependent on temperature more so than in the standard resistor thing. So like the what is portmanteau of the thermal and resistor thing, means how the thermistor it is came into picture thing. Okay, so there are some of histories are there. Okay, so thermistor was first discovered by the Michael Faraday 1833. Maximum people know this Faraday thing. Although commercially useful in thermistor is manufactured in 1930. See, it took around 100 years, but now the scenario is different. If you are developing something, then people are there. If it is having the efficient and competitive product in the market, immediately people will be there to take the product into marketing. So it took around 100 years. So thermistors are type of semiconductor, meaning they have greater resistance than the conducting material, but lower resistance than the insulating materials. So there is a two type of your thermistors are there. That is your negative temperature coefficient, another your positive temperature coefficient. So that means negative means if the resistance is your increasing with the temperature thing, means if the temperature is increasing, resistance is decreasing. And other thing is your temperature is increasing, then the resistance will be increasing. And once it is decreasing, the resistance will be decreasing. So now another is your RTD. See the thermocouple, then thermistor, then it is coming to another is your RTD. This RTD, why we are talking about this RTD? Because it is something out of the thermocouple and your thermistor. Okay, it is providing a stable type of your the temperature deflection thing. What it is saying, this is a temperature sensor that operates on the measurement principle that a material's electrical resistance changes with the temperature. Okay, and resistance thermometers, also called as the resistance temperature detectors or the RTD things. So we are just talking about this temperature things. Yes. So there are yeah. Basically it is comparing what is the which one we should take. Okay, so in that case we need to see, because if we will come to this one, no, so question is, if we know these principles, one is your thermistor, thermocouple and RTD, then which one we will be choosing? Then you need to decide which temperature range you are working. Think of that your temperature is very limited, like 25 degrees centigrade to maximum your 100 degrees centigrade. That time which one selecting. But if it is your like your minus of something to around your 400 degrees centigrade thing, then another is your something your 0 to think of your 1200 degrees centigrade. So for various purposes it is there. If you will see, the if the process temperature are between minus 200 to 500 degrees centigrade, okay. Yes, somebody please uh, yes, please mute your mic. See, if the temperature, just like I told you here, no, so the range you need to know. So with that, if it is your minus 200 degrees centigrade to your 500 degrees centigrade, then this RTD will be preferred one. This RTD is very ambient under this thing, means very performing well under this thing. But thermocouple has the range of your minus 180 degree up to your 2320 degrees centigrade. Okay, but problem is, if the range is increasing, then the resolution will be less. What is the meaning of resolution? That means it is ranging from your minus 180 degree to your 2320 thing. Then think of that there is a minimum changes in the 5 degrees centigrade. Then in that case, whether it will show you the 180 or you 175, that is exactly you cannot find it. Okay, so that means the resolution is not proper. Okay, so they are only contact temperature measurement devices. That means in contact you can put it. So like so these are the nothing but various parameters to choose which temperature sensor you will make. Now this is type of your stress strain we know. Okay, so now strain gauge. This strain gauge, see what we have shown you, these things are in terms of your, if I'm making this strain gauge in a micro scale, okay, a very minimum scale, the micro level wires I will making, then this one we can use for a the smart watch also. Okay, that means in that case also, if some strain is there, some stress is there, then means because some pressure it has come, so with that it can able to sense it. The strain gauge is a sensor whose resistance varies with the applied force. So if you will see, there are A, B, C, three things are there. So in this case, this is the normal thing. This is at the normal position. So here the strain sensitive patterns are like this, and these are the two terminals. Think of that it is pulled one, the tension is given to this one, the higher resistance it is observing here, because see the wires it is extending, that means the resistance it is increasing, the tension area narrows and resistance increases. Okay, high resistance. But if you will see the in this case the area thickens but resistance decreases, that means we are squeezing this thing, but here we are elongating this thing. So this is the principles are there. So now how you will get the change in the strain? For that, if you will take a Bridgestone type of circuit, in this case there are three known resistance we will be putting, R1, R2, R3, and the strain gauge we are putting. In this case either we are elongating or squeezing. Because of that, the whatever resistance change will be there, that will be deflected, okay, with this B means thing. Okay, so that is your the gauge factor GF is defined as GF equal to delta R by Rg by epsilon. Okay, so that delta R is the change in resistance caused by the strain, and Rg is the resistance of the undeformed gauge, and epsilon is the strain thing. So that means it is during undeformed how much resistance it used to put it, and delta R is nothing but the change in the resistance, and this is the how much strain it is coming. So that gauge factor it is calculated. Potentiometer, you might be knowing this thing basically when people are there in terms of your engineering or the first years, they used to know about this thing. Even in the physics also we used to hear this thing. A potentiometer is a three-terminal resistor with a sliding or rotating contact that forms a adjustable voltage divider. If only two terminals are used, one end and the wiper, it acts as a variable resistor. So this is the variable resistor. That means one side contact is there and this one is moving. Okay. So at this point means this much of resistance. At this point means maximum resistance it is there. Okay. But 3 points are there means it is nothing but voltage divider. Where you will be requiring this one in case of IoT, think of that manually you are adjusting the light, the how much it need to glow. Okay, so with that you need to know about this thing. Okay, the means only one example I'm giving, so anywhere you can put it. The measuring instrument called a potentiometer is essentially a voltage divider used for measuring electrical potential, right? So then it is coming to some of your optocoupler. Okay, so I will skip some of the things. Microphone, we know this thing, carbon microphones. That is, if you will see what is the pattern it is making, if we will see microphone means where we are talking this thing. So think of that some sound waves it is coming, because of that the granulars what is there, how they are making the shape and it is hitting to this fixed electrode. That means this is your diaphragm where it is hitting the sound wave, and inside the carbon granules are there. Okay, so what is saying, the carbon microphones also known as the carbon button microphones or button microphones is a type of microphone that is converting the sound to an audio signal, electrical audio signal. It consists of two metal plates separated by granules of carbon. One plate is very thin and faces toward the speaking person, acting as a diaphragm, and sound waves striking the diaphragm causes to vibrate, exerting a varying pressure in the granule, which turns that change into electrical resistance thing. So just like that, in the case of your dynamic thing, this is nothing but your sound input it is given. Okay, here this wires, if you will say, this is the coil thing. Okay, this is making the movement of this thing, and because of this movement, the resistance it is changing and the alternating voltage output is running. So dynamic mic consists of diaphragm suspended in front of a magnet to which a coil wire is attached. Coil sits on the gaps of magnet, and vibration of diaphragm make the coil move in the gap, causing the AC to flow. Okay, so this is your piezoelectric microphone. What I said, through this the sounds will be passing through, and this is the upper layer or piezo element is there, and because the pressure thing, okay, it is making some movement to this one, and with the movement it is making the sound thing. The piezoelectric transmitter has the advantage over all other type of mentioned thing, can bonded to a solid or immersed in a non-conducting liquid so as to pick up the sound signal in any of these carrier. Okay. Now this is a chemical gas sensor, so I will talk about this thing. Like a silicon substrate or wafer will be taken, and these are the two boundaries we made it. Okay, so one is SU8 boundaries are made it, and the contacts are nothing but your gold thing is there. So here what we are saying, if in this case the antibody and is there, okay, what is that, if we are putting some drop to this one, with that what are the portions it is only attaching to this one, means the buffer thing, that is only giving you the result that how much the phase difference it is occurring, if it is a wave type of thing propagated through this thing, or the weight thing, what are the loading effect it is coming to thing. So that is means only the what are the portion, think of that a what it's saying, using an SU8 photoresist constructed high aspect ratio wells which can contain the polymer carbon black solvent liquid volume present during the deposition and allows the sensor film to be placed reproducibly in a specific and well constrained area, which reducing in the overall size. And the carbon black composite film have been used in the sensing medium in several gas sensors or electronic nodes. That means what is that, think of that again, I will give you an so this example only. So if we are putting through the syringe, we are putting this polymer film to this one, and already the parties or particles which are able to, think of that this is a Mm, suppose a CO2 type of thing, this carbon, this is gas sensor then, so carbon dioxide I want to detect it. Okay, so what is that, here we are putting a chemical which can attract only carbon dioxide molecules out of the air thing. So in a gas chamber we will make it, and we will force a area sample, okay, some air sample we are putting into this one. So in that case some other particles will be there, think of that some carbon monoxide is there, or some oxide is there, or other things are there, but what are the CO2 particles, they will be only coming and sitting over it, they will be coming and sitting over it, and others that will be removed. And because of that, so there is, see, previously there was some weight of this thing, it is exerting some of the pressure because of these particles, and when the CO2 it is coming to change place, they are sitting on this thing, that time they are providing some other type of pressure to this thing. So because of that there is a pressure change is there, through that it is nothing but detecting how much your that CO2 thing it has came into set. So in the air how much carbon dioxide is there, it is deciding. This one is also cantilever type of thing, so in each of them it is going to be setting the molecules, and because of that deflection it is occurring, and that deflection will give you that how much resistance change is occurring, because the if it is elongating now, how much resistance change is occurring. So with that it is giving you the sensing thing. So the basic hardware parts I shown you, and when you are talking about this IoT thing, the same thing only there, but in a micro scale chip way, in terms of chips we are making, like a pressure sensor, it is this one, this is your ultrasonic distance sensor, that means one side it is detecting, so it is sending signal, other side it is receiving, with that it is detecting that what is the distance it is happening. So this is your analog temperature sensor. Okay, at this one steel plate will be there. Okay, with that if temperature is there, then heating, through the heating it will is detecting. Tilt sensor, this is nothing but how much angle it is made, then infrared motion sensor, then camera sensor. So these things are the camera sensor means it is nothing but taking the pixels or the picture, or if a still picture is there, then what is the pixels. Okay, so in terms of your actuator, it is component of a machine system that moves or control the mechanism of the system, and the actuator acquires or requires a control signal and source of energy. So various actuators, hydraulic, pneumatic, electrical, thermal, mechanicals are there. Hydraulic, it consists of hydraulic cylinder or a fluid motor that uses hydraulic power to facilitate mechanical operation. The mechanical motion is converted to linear or rotary or oscillatory motions. Since the liquids are nearly impossible to compress, a hydraulic actuator exerts considerable force. So this type of your hydraulic actuator is that. So if you will see in this case with the liquid thing, if you will put it this pressure thing, no? Okay, so it is coming forth and back, it is moving forth and back thing. So this is nothing but your the pulse, a radial engine acts as a hydraulic actuator thing. Pneumatic actuators convert the energy formed by vacuum or compressed air at high pressure into either linear or rotary motion. Pneumatic rack and pinion actuators are used for the valve control of water pipes. So it quickly responds to starting and stopping signals. So this is your pneumatic actuator examples are shown here. This is your manual linear pneumatic actuators, and this is the air pump act as a pneumatic actuator things. This one, electrical actuator, generally powered by a motor that converts electrical energy into mechanical torque. The electrical energy is used to actuate equipment such as solenoid valves, which control the flow of water in pipes in response to the electrical signal. So motor drive based on rotary actuator. So this is a solenoid type. So thermal and magnetic actuator, these can be actuated by applying thermal or magnetic energy. They tend to be compact, lightweight, economical, and with high power density thing. So there are actuators uses safe memory materials, safe memory alloy, or magnetic safe memory alloys. What is the safe memory alloy? That means if a wire is taken the safe memory material, in this case if I want to bend it, okay, so the same thing, the same this line was there, no? So this one I want to bend it. So think of that this wire, this normal straight line wire, this is the memory of your 25 degrees centigrade. At 25 degrees centigrade, this is remembering that this is the size. And if you will make it to 40 degrees centigrade, immediately it will make the 90-degree angle, 40 degrees. So this is nothing but your, with the temperature change, it will remember some of your sizes. So because of that, it is nothing but called the safe memory alloy. Now it is one of your piezo motor using SMA thing, same memory alloy thing. So either you can say that suppose uh, when we are providing some voltage to this is the SMA thing, this is your SMA thing. So this is a piezoelectric thing. So think of that with this thing, we are providing some piezo thing plus and minus thing, and in that case, so there will be blocks. It is not like this straight line. This will be block type of thing will be there. So in this case, because of the positive and negative we are providing, we know that in piezoelectric there is a character of it is deforming. Okay, so providing some voltage, it may elongate it. Okay, if we are removing the voltage, it will contract it. So with that, so when the elongation is there, then it is making this type of shape, and contraction means it is nothing but making this type of shape. That means this one can able to move here. In this case, this one can able to move that the lower bottom side also it can able to move. Coil gun works with the principle of magnetic actuation. Okay, So now I will come to, okay, yeah, this protocol thing, IoT architecture layer. So those are sensor and actuator parts. Some of the parts I have left. Basically, the client side IoT device layer is there. Okay. Then operator side, then IoT gateway layer is there. Then pathway of connecting clients, the IoT platform layer is there. So these are the different architecture layers are available. Okay. Now again it is coming to the communication, because those are the sensor actuator hardware part is there, and under the communication I will skip some of the parts. I will come to the layer thing when we are deciding, no, these things I will come to the layer thing. Okay, okay. So this deployment layers, because when we are providing a IoT device or we are designing some IoT device, okay, that time when we are designing some IoT device, that time it need to be categorized under which level it will come. That means the standard of that level means that looking to the communication protocol used in the device design or development, it is categorized into different levels. Like IoT level 1, in this case it is just like at the local section only it is working. The application layer will be there. Okay, one, we can keep it a one database, and the controller service, resource service and node thing. Or you can come from top to bottom, or you can go from bottom to top. So think of that, this is a monitoring node is there. Monitoring node means I told you what is node. That is a, either it is a sensor or a actuator thing. Think of that, this is a temperature sensor is there, and here it is detecting the temperature of the this environment where it is placed, and through that the information it is passing through the database thing. Okay, and in the database it is keeping, and if it is requiring something like to act on, like because of the variation in the temperature it need to act on, then through the application again it is given command and it is coming to here. That means here there is no need of any internet is there. We need not to go for any internet or any cloud thing. See, cloud side it is empty, it is working in the local way only. IoT system has a single node that performs sensing or actuation, stores data, performs analysis and hosts the application. IoT system are suitable this level type of thing for modern low cost and low complexity solution where the data involved is not huge and the analysis requirements are not computationally intensive. Second level, here it is just like your level 1, but simple, the database we are putting in the cloud. That means it, in the structuring of the design it changes. That means when we are structuring this thing, so if you will see there is a complete change is there. Whole thing it was working in the local side, but now it has come to the cloud side. IoT system has a single node device that performs sensing, actuation, okay, local analysis. Data is stored in the cloud. So this is the change. And IoT systems were suitable for solution where the data involved is big. However, primary analysis requirement is computational intensive. Means there is need not have a high intensive computational required. Three thing, 2 and 3, they are looking like the same thing, but what is that, in this case the data size will be high. The data stored in analyzed in the cloud application is cloud based, and this is suitable where the data involved is big and the analysis requirement are computational intensive. If you will see here, not computational intensive, but here computational intensive. That means whatever the machine learning algorithm is required to decide the action, so that is quite intensive. That is the case of your cloud 3. So that means the, see, if you will see the node is one only, the sensor node, what is that, that is one only. Okay, the device resource controller and database is kept in the cloud thing, and app it is controlling the application thing, it is controlling thing through the cloud thing. Now see, now it has come to little bit complex. Up to, if you will see, level 1 it is very simple. 2, because what are the BTech level projects they are doing, this is type of this thing, or maximum up to 2. But when you are coming to 3, this is little bit pressure you will be holding. But coming to 4, this is required very much attention. Why? Because you will be using multiple nodes. Multiple nodes you are required. Okay, multiple type of sensor, temperature will be there, water level detection will be there, humidity will be there, all the things it will be taken care, and that will be sent to the database. Meanwhile, in the cloud also it need to compute it very intensively. That is, this is suitable for solutions where multiple nodes are required, data involved is big, and the analysis requirements are computationally intensive. This is the level 5. Another level high, what it is doing, if you will see what is the difference. In this case directly we are taking from this thing, but another thing, there is a coordinator it is coming to between them. That means between these two nodes another coordinator is there. From there it is taking, it is deciding that whether what is the average value it will be taken, and with this it is sending to the database, and so it is becoming more complex. This thing suitable for solution based on wireless sensor network in which data involved is big, and the analysis requirement are computationally intensive thing. These are last and more complex thing is that level 6 IoT system has multiple independent AND nodes. That means it is not only it is shown as 2, it has shown as 2, okay, but multiple nodes will be there that perform sensing and actuation and send data to the cloud. Data is stored in the cloud and application is cloud based. The analytics component analyzes the data and stores the result in the cloud database. The results are visualized with the cloud-based application, and centralized controller is aware of the status of all N nodes and sends control command to the nodes. That means in this case, this is more complex one, though there is a multiple nodes will be there, then centralized control will be there. From this, it is connecting to the devices, to the resource file, then to the controller service. Then from here also, it is coming to REST or the WebSocket service, where it is sending the database, means it is putting the values in the database. Here the observer node, what it will do, it will see the what the average it is taking. So multiple tasks it is working. If you will now, I will compare with level 1 to level 6. Just see how many phases are there, or how many blocks are there. In level 1, one local, it is working in the local application thing is there, REST or WebSocket communication, where this service is there, then database, controller service, resource, device, and node. So node to device to resource controller, this is one part. Okay, then the database, and this side is your app and WebSocket. Now it come to level 6. If you will see, there is, you will be having the local level working. See, there is a observer node at the local level, there is a observer node at the cloud level. The app is applied, the application which is we are working on that, that means through which we can able to control it manually or automatically, the application, it is in the cloud. So if you see, this is the complex one. If the what are the major projects are there, what are the major projects are there, those are based on this level 6 type of your work. So various application already we have seen: education, food, pharmaceuticals, logistics, retail management. Challenges are that I have not given many examples because the content is too high, means too much of content is there. But if I will talk about one of the example to discuss about the issue thing, think of that. So smart parking is there. In smart parking, if think of that, this one, two, three, four, that means this place, this place, this place. So this side four and this side four are there. Okay, so here the car can be coming and parking here. Okay, and once the time is over, it need to remove the car from this place. But if it is extending this thing, okay, then it has to pay the extra money. But in India, we means I'm not, suppose in our nation, if some good type of people will come, say that no, I will put it for one day and I will not pay you. Then for that also some restricted rules need to be passed, that if you are making this way, you are offending this way, then you will be coming under these rules. Okay, so that thing, it is for the people, for the society, then only it will happen. So that is one of the physical example I'm giving, but there are so many software level or the security level issues also there. Policy for people in the Internet of Things is legislation required. Environment aspect, resource efficiency should be there. Pollution, disaster avoidance will be there. Technological, architecture, governance, naming, identity interface, then service opens. Okay, connection, real world, real or virtual world. Then standard. That means if you will say in the issues in the society, this type legislation, this rule it is coming. Policy, the same rule, I will say that policy and legislation, the same thing it is coming to this one. Environment way, we should be working the resource efficient way, or the pollution, avoiding the pollution type of things. Technological aspects, we are talking about this architecture or the governance thing or service thing. Okay, so these are the some of your challenges are there. So plan to growth, plan to IoT growth, additional type of logging, log storage, can you find needle in the haystack? So that means if you will find that, see, there are so many problems will be there. Okay, so those things we need to remove it and solve for that same thing. Because if you know that there are so many bugs are there, every time if you are writing some code, definitely some bugs are there. So because of that box, if some security concern is there, then definitely those things we need to work on it. Strengthen partnership with the researcher, vendor, and procurement department. This is very interesting line, because IoT will work with all the partnership only. No one is going to work single-handed and get it. So this much of your thing was there, and these are some of the references are there. Thank you. If you have anything, you can talk to me.